Hello friends. So in this video, I will try to find the solution to this integral. So this integral is useful uh, in various topics in physics that has to do with finding the partition functions of phonons, or even in case of the black body radiation, which or the Stephen Boltzmann law, that is derived from the partition function of photons. So let's see. So you see, the first thing we can observe is that looking at the integral, the first thing is that you see 1 plus e power minus x plus e power minus 2x plus dot 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 is equal to summation k equal to 0 to infinity e power minus kx is equal to 1 over 1 minus e power minus x. So this is just the geometric series, the geometric sum. Okay, so this is written like this, so I can substitute it here. So the integral will then become, so I will just let me just circle, oh sorry, so I am just writing the sum. So okay, so I just wrote the sum. So there is one more point, is that I exchanged the sum and the integral. I brought it out. So as here all the functions are well behaved and smooth. Okay, so I can do this thing in this case. This is always not possible. But anyway, so after that, you see, let me write it as summation k to 0 to infinity okay. So I just rearranged them. Now you see, in one of my videos, in the previous videos, one of my previous videos, I have shown that Laplace transform of t power n, which finally is a function of s, and written as minus ts t power n t is tau n plus 1 s power n plus 1. So this is one of the important formulas. This is the formula about Laplace transform. So you see, I will use this here, so you can clearly see the form that I want, except instead of s, the function that will come out will be a function of k plus 1. So let's put it there. So summation k equal to 0 to infinity. This entire integral is nothing but tau n plus 1. I used here capital N, but here small n. Okay, so I mean both are same. So tau n plus 1, you have k plus 1 power n plus 1. Okay, so I just used this thing. So now you see, now let me do one more step. So k plus 1, k goes from 0 to infinity, k plus 1 goes from 1 to infinity. So I will just rename the variable. So now t power n plus 1, yeah, okay. So you see, now I will say one more thing, is that look at this function, summation t equal to 0 to infinity 1 over t power n. This is the Riemann zeta function. This is the Riemann zeta function, and some of the values of Riemann zeta function are known. So this is the Riemann zeta function. I'm going to use it here. So I'm going to get tau n plus 1 times the Riemann zeta of n plus 1. So you see, so it is a very beautiful thing. You can see that. So the gamma function is, I hope you know, so gamma function is gamma of n plus 1 is just n gamma of n, which is just n factorial. Okay, gamma functions are defined this way, and they can be analytically I mean, like, the factorial is defined only for the integer values, positive, but you can do a analytic continuation over the whole R2 plane for these gamma functions. But anyway, so you see, now we have managed to solve this integral. This was our aim, and we have solved it in terms of two of the most most beautiful functions in mathematics, like, arguably. So one is the gamma function and another is the Riemann zeta function, which I showed it here. And now for any value of n, you can substitute here that n, and you can look it up, or what are the values of this. I mean, this can be just written as n factorial if n is an integer. Okay, so this was a short video on how to on deriving this beautiful integral here. So that's all for this video.